Okay, in today's session we'll see what were the new features added in Java 6 to particularly support collections. Okay, see in Java 6 there were hardly any changes in the language, only they went on to add some classes and interfaces to support the library. So means they gave some extra support to some extra data structures. Okay, so here you can see there are Deque, there is the different classes and interfaces which are added in Java 1.6 are Deque interface, ArrayDeque, NavigableSet interface and NavigableMap interface. So this was what was actually added. And if you see the history of collections in Java, collections framework in Java, here you can clearly notice. See, initially when Java was released, in the first version of Java, there were hardly support for only 5 data structures. Okay, and they were synchronized also. So there was some performance issue. So it means you couldn't use these classes in multi-threaded environment. Then in 1.2, the collections framework was created. Till 1.2 there was no collections framework, only simple classes were there. But in 1.2 a framework was created. Their idea of creating framework was to work with a uniform approach to all the data structures. So that was invented, and more support they gave to what? All the data structures. 1.3, 1.4 some minor changes happened. Don't worry much about that. Okay, but in 1.5 is what a massive change took place to support collections framework. Okay, and in fact the change came in the language itself to support collections framework. Here some library means some more classes and interfaces were also introduced, and at the same time some syntax change means something new they added into the Java language also. Okay, so what was added in Java 5 to support collections means enhanced for loop. That was one which was added. Then auto boxing was added, and at the same time generics was added. Okay, so this caused a massive change in the language itself. Okay, so that's why always Java 5 they say there is a massive change, massive change. So apart from those changes, a new class was also added called as priority queue. And in Java 1.6 what happened was, okay, that was about that's the story of 1.5. Okay, change in the language plus some addition in the libraries. But in Java 1.6 only change in what? Only addition of new classes in the library. Only new addition of new classes. And those classes are classes and interfaces are NavigableSet, NavigableMap, Deque were introduced. Okay, so in 1.7 some small changes there. That's only one diamond operator was introduced. We'll see that. So this is now the revolution of which one collections happened in Java. So see why I went on to cover collections in this way is tomorrow you might get more versions, 1.8, 1.9 or extra it can continue. Okay, my idea of teaching you collections was this, very simple. Like see, collections is something which is giving you support to data structures. Tomorrow again Java might increase their library to give support to other structures. So that time you only have to concentrate on the data structure rather than implementing it. Understood? So generally what happens is people learn Java in a by-hearted way, which is a wrong approach. So here Java language is very simple. Okay, it has got very few things in the language, and after completion of the language they say use our library. Okay, so Java is a very simple language which ends in say 30-40 classes. Okay, and rest all what you study in Java is only library. But to understand the library here concepts are important. So until and unless you know the concept, it is very difficult to understand what support is existing in the library. So from day one I am going on teaching only concepts rather than output. Okay, if you know the concept, that solution is already there in Java. So this is the approach I have taken. So even tomorrow if 1.8, 1.9 version comes, you just have to adapt. Adapt means what? Adjust to it. Okay, see generally people will think, okay, 1.8 means I don't know. Hardly what will be the changes? Some minor changes and some extra classes will be added into library. That's what they do. Okay, so you should be ready to adjust to this kind of inventions which keep on happening now. Done? Okay, so we're done with this. Now we'll see what was added in 1.6. Yes, as I told you in 1.6, yes, these were the different classes and interfaces added. Okay, so here Deque was added to support double-ended queue. So it's an interface. Deque is an interface which supports what? Double-ended queue, and that is implemented by which one? A class called as ArrayDeque. ArrayDeque is a class which is implementing this. So let's understand what is double-ended queue. Yeah? Okay, see, in fact, forget Java now. Let's come to some concept, which are data structure concepts. Okay, later on we'll see how Java is supporting this particular concept. First, let's understand the data structure concept. In data structure concept, there's one important data structure called as queue. And in queue also there are many types of queue. There are many types of queue. Example is you got basic queue, priority queue. Okay. Then we are going to see something called as double-ended queue. So like that, many types of queue are there. So some of the queues which we have studied are the basic queue. So in the basic queue, what happens is you have something called as LIFO, means last in FIFO. So you have something called as FIFO, first in, first out. Okay, that is basic queue. So then you got something called as priority queue. In priority queue, unlike FIFO, here the preference to be given to some particular value. Okay, so that value will be the, one second, or we'll see this. See the basic queue, priority queue, and as well as something like double-ended queue. See, basic queue in Java, this particular data structure is supported by the class called as linked list. Okay, priority queue is supported by the class called as priority queue. And double-ended queue is supported with the class called as ArrayDeque. So these are the different classes which has been provided in Java to support the different queue now. So you have to understand the concept, then you'll understand what is this class now. Understood? So now ArrayDeque's main invention, or why they released in Java 6 was to their basic intention of releasing ArrayDeque in Java 6 was to support double-ended queue. But in fact, even though it was introduced to support double-ended queue, it can support some other data, even all these queues now. Means it can support the ArrayDeque can also support, you can use it as a basic queue also, as well as you can use it as a double-ended queue also. As well as you can use it as a stack also. So it supports three structure. In fact, that was the main intention. Okay, but even though it can support double-ended queue, other two structures also it can support, which is basic queue and stack also. So see, initially up till 1.4 version, we were using linked list only as what? For the support of basic queue. So just to highlight now what had happened, see the first one, basic queue. So in the basic queue, see this will be the data structure. So this will be the front end and this will be the rear end. This is the concept now. So in front end you remove values and in the rear end you add values. So and it uses the FIFO, first in, first out. What element is entered first will come out first now. This is how the basic queue has been designed. And here in Java it is supported, means we take the help of a linked list class to get the support of this. So basically see, even though we represent it like this, we have something called as pre-next. This is linked list. So we'll use some methods, that's it, of linked list and convert that linked list into what? Means we'll use that linked list as a queue now. Okay, so this will be front end now and this will be rear end. This is how you'll use the linked list. So for implementing the queue, we use linked list data structure, that doesn't matter. So for which data structure do you use to get the help, to implement the concept of queue is secondary now. But in Java they are telling use linked list for this particular purpose, and that is why you find some methods in linked list called as add first, add last, remove last. These are the different methods present in linked list to support what? Basic queue. Okay, so this is their idea. This is double linked list. Okay, so this is the concept and we implement it in this particular way now. So up till 1.4 you are doing like this. Okay, so this was the support what you are getting. Now coming to the second one, priority queue, which was added in. So again this is the concept. Priority queue is what? One concept, and let us see which class is supporting that. So priority queue is a data structure again. So I'll write P small so that you understand it's a data structure, and it is supported in Java with the help of a class called as priority queue, which was introduced in Java 5. Okay, so here what happens is, see, in priority queue, so this is how it works. Priority in, here priority in is nothing but a value. So in priority queue, to implement that, okay, what happens is they use something called as a heap. Heap is nothing but again something called as a binary tree. See, whenever you put values into this priority queue, okay, all values will go on getting stored here. So 5, 9, 8, 10, 11, 12, 14, like this. It will be stored in a heap. But heap is nothing but actually a binary tree only. Okay, so see now, to implement priority queue, they are using the heap data structure. It is irrespective which data structure they use to implement that, but the concept of priority queue is very simple. So when you put the values into this, fine, but when you are getting the values out from the queue now, priority queue, actually it comes out, the minimum least value comes out. Means priority out will be, priority out means we'll be using the poll method. When you use the poll method, see, this is how the values will start coming outside now. The first preference or the highest priority in priority queue will be given to the minimum value. The highest priority will be given to the minimum value. Means first, even though you put so many values, you can put it in any order, that is irrespective now. But when you start pulling out the values from the priority queue using the poll method, first preference will be given to the minimum value. Then next will come, which is the next one? Example is 8, then 10, then 11. So like this the values will start coming outside. So queue will be formed and poll method starts pushing out the values in this particular order from that particular data structure now. Means priority queue means it is giving out the elements based on the priority. Priority, and the highest priority in priority queue is given to what? Or the highest preference. The highest preference or the highest priority is given to the least value. Okay, if you want you can change it to give out the highest value also, but by default the priority queue gives highest priority to the minimum value or least value. Understood? And this is very important data structure, because this data structure is used in many applications today where bidding and all happens, online bidding, like you buy tickets, online tickets and all that. So all the values will keep going and getting stored now, and the first preference will be given to what? The highest value. So there you can use on comparator and change the output. By default it will be giving out the minimum value. If you want you can change that, reverse that by using the comparator. So that is basic queue and this is priority queue. So you see, check out, that is the queue concept. But basic queue was implemented with the help of linked list. Priority queue was implemented with the help of heap data structure. And heap data structure is nothing but what? Binary tree. Don't worry more about that, but this is how it works. And such a terrific concept is given to you with the help of which class now? Priority queue class. So if you use priority queue class, fine. Just you can add all the values, okay, using their methods, and just keep calling poll. Poll method if you call, keep calling, what happens now? The element from that structure will be returned to you, means it will give it out from the head. It returns you the head of the queue, but the head of the queue will always be what? The minimum value. Understood? So that is what they have done. And the third thing, what you have to understand right now today is, what is a double-ended queue? Concept first you'll understand. Once you understand the concept, now that will be implemented by which class now in Java? ArrayDeque class. Simple. But basically what is double-ended queue? See, a double-ended queue is something like this. Okay, where you can, so you'll have two ends for a queue. You know that. You have the front end and you have the rear end. See, these are all terrific concepts. So you can add value in front end as well as you can remove value from front end. Both you can do now. Again you will add value in rear end and also you can remove value. Where in? Rear end. So this is how it works. So this will be the front end and this will be the rear end. You getting the idea now? Just a second. This is front end. This is rear end. So you can add value here, add plus remove value here. Here also you can remove value. So you can add and remove value from both the ends. So that is what you mean by a double-ended queue. So now compare all the queues, you'll get the idea. Okay. So one more thing is here. For implementing this double-ended queue, internally they are using array data structure. They found that if they use array for a double-ended queue, it has much more better efficiency. See, for implementing this queue concept now, they know if you use which data structure internally, it gives you better efficiency. Okay, like see, for basic queue we are using which one? Linked list. They know that linked list will give you a good support for basic queue, efficiency wise. Similarly, they know that, means Java people are doing R&D for that. For implementing priority queue, they know that if you use heap data structure, it gives you better efficiency. Same way, for implementing double-ended queue, they thought that array structure is better for better efficiency. Understood? So they'll decide, they'll sit, do R&D and all that, they'll do all the, means efficiency means we do the operations, which one, insert, update, delete and all that. No. For those operations, it should support you in a very high accuracy, means in a very high efficient manner. So due to that, they do this R&D and they come up with these kind of solutions now. And you got the idea now. So basic queue you'll use which class now? Linked list. Priority queue will use which class now? Priority queue class. And for double-ended queue, which class now? ArrayDeque. And one more point now, just to mention again, to highlight, this double-ended queue also gives you the support for what? Yes, it can give you the support for, see, initially it was designed for double-ended purpose only, but it can help you to, means you can use it as what? Basic queue. Which one? FIFO. You can use this one class to support FIFO also, first in first out. Both it will support basic queue plus double-ended queue, and at the same time, just to highlight, it can support what? Stack also. So that is the concept now. Now we have to understand that with an example. Understood? This is the concept. So this concept you have to understand with an example now. Just I'll introduce that class to you. I show you some output or output. Once I start showing the output, automatically you start understanding the same concept. So ArrayDeque is implementing this particular concept. Done now? So any questions here? Clear? Everything clear now? So let's straight away get into that, which are now? Document. And I'll explain you all this. So what is priority queue? Sorry, what is ArrayDeque? So we are going with ArrayDeque today. Okay. So what is ArrayDeque? See, this is how it looks. Okay. So you can insert and delete from front end also. At the same time, you can insert and delete from rear end also. Both operations you can do. So this is how a double-ended queue looks. And the class which implements this is ArrayDeque. In fact, all the methods present in ArrayDeque are present in Deque interface. So when I am teaching you ArrayDeque, I am actually teaching you the methods of Deque interface. Understood? So yes, see this? Deque interface and ArrayDeque class were added in Java 6. They are added in Java 6. Both are present in what? Util package. And then ArrayDeque is a class which implements Deque interface. Getting this basics now? Yes. Now see, Deque interface supports double-ended queue. That's where it starts off. Deque also supports basic queue, means FIFO. First in, first out also it supports. And at the same time it supports stack also. Okay, that is LIFO, last in, first out. So Deque interface has push and pop methods to support stack. That's it. To support that structure, what they'll do? They'll use some methods. More than that, they'll not do anything. Fine. It is more recommended to use what? ArrayDeque as stack rather than the legacy stack class means, see, when Java was introduced, Java had given support for data structures long back. Okay, here when they had given the support for which one? Only few structures. Later on you can see they didn't give any support for what? Stack only. They told you if you want to use the stack and queue structure, better you use linked list. In fact, earlier we developers were using linked list only as stack and queue. It was supporting all the three. Basic linked list was only supporting all the things. Okay. So why were we using linked list as stack and queue? Why not stack interface? Why not class stack? Because it was synchronized. Since it was synchronized, we were using the linked list to support all the three structures: linked list, stack, as well as queue. So we didn't have a dedicated one. So in Java 1.5 when they released, they gave a dedicated support for priority queue, which was not there at all. So in Java 6 what they did was they gave a dedicated support for what now? Queue today. So that's why you can use ArrayDeque as basic queue, double-ended queue, as well as stack. All the three you can use, and it is asynchronized. Yeah. So coming to this document again, you see. So it's more recommended to use ArrayDeque as stack rather than the legacy stack class. ArrayDeque class is likely to be faster than stack. Why? Because it is synchronized. Stack is synchronized. ArrayDeque is not synchronized. That's why it will be definitely the performance will be better when used as a stack and faster than a linked list when used as a queue. It is very clearly documented. Okay. Then ArrayDeque is using which structure internally? Array structure. So why do we have to bother? We are getting our support now. What support? Double-ended queue support, basic queue support, as well as stack support. That's all we have to look into. So ArrayDeque allows what? Dissimilar values. We'll be seeing with examples now. ArrayDeque also does not allow null values, and it stores. Yes, this is one more point. What you add? ArrayDeque stores values in same order as inserted. Means how you insert, it will store the values in the same order. Understood? So let's see this now. So I have to give you some examples, and this is the diagram. So you have got the concept now, and we have to only understand with them program now. Okay, so let's see this now. So what we'll do is, see, I've already got this code here. In fact, you go to D drive, Eclipse examples, August 2013. Yeah, you know our folder structure. Yes, here I've added one more new workspace has been created called as util package collections 1.6. So I organized it clearly. Up till 1.4 what was there? In 1.5 what was added, and next what was added in 1.6. So this is a new workspace. Okay, so what I'll do is, I got already the projects here. I'll open that now. And now we'll see how the ArrayDeque works. We'll take the first example. In fact, to understand the first example, you should know the different methods present in what? ArrayDeque. So it has got various constructors. So ArrayDeque is extending what? Object and implementing these many interfaces. It's implementing deque, queue, and collection. So the hierarchy is what now? For ArrayDeque, you have collection. Now collection is a queue is extending. Queue is also an interface. Extending which one? Collection. So then deque is what? One more interface. Extending what? Queue. And you have now ArrayDeque which implements queue. ArrayDeque is implementing deque, deque is extending queue, queue is extending collection. This is the hierarchy. Understood? So always remember the hierarchy. So now first basically I'll show you the different methods which are present in collection. The different methods present in collection which can be used for what? Any data structure in Java. Yeah. So first we'll see the different methods. This is implementation. This is dotted line. Dotted line indicates what? Implementation. This is a straight line which indicates inheritance, extends. So this is implements and this is extends. Okay, fine. Now coming to this, there are many constructors you can see. Done. And first we'll go with some methods. So there are some methods which exist in which one collection interface. Which are the different methods, you know? Some very common: add, okay, then clear, clone, contains. These are the common methods which are coming from collection interface. So ArrayDeque has to implement that, and we'll first basic example we'll see is of that itself. Yeah, this is the first example now. So I've got here ArrayDeque. Go to this project. In this project I have got ArrayDeque as the first example, and here I am covering only what? The methods of collection interface. You can see the values now. Add, understood. And here I am showing you without generics. There's a reason why I am showing without generics, because here I want to show ArrayDeque supports what? Dissimilar values. So if I restrict using generics here, that time I cannot add what? String here. So that's the reason, to make you understand what all you can add. I'm not using generics, and I cannot add null value. Yes. So then display all values. If you want to print all the values, print it, and toString has been overridden, it will print all the values. Then size. So size is a method now. So size, this method comes from which interface? Collection interface. Then next, contains is a method which comes from collection interface. Remove. So contains means what? You're checking whether that particular value called as 5 is present or not. Then I'm telling remove. I'm checking means I am removing a particular element. Remove the 4. The value called as 4. I've added 4 here. See, where is 4? Here. So the 4 will be removed now. And lastly I am calling clear. Clear means what? All the values will be removed now. So let's see it. So these are the different methods of the collection interface. As you can see now. See here, 1, 5, 3, 4, 6, 2. Yes, we added the same values. And it's inserting in the same value. See, the order. The order is same now. In what order I inserted the values? The values are present in the same order now. See this. I inserted as 1, 5, 3, 4, 6, 2. A also. It is inserted. Done. Next. I printed SOP. Fine. Size. Size is a method which gives you the number of elements then. Understood? So then next, contains. Does it contain 5? Yes. The value is present? True. Return type of contains is what? Boolean. Then if I want, I can remove a particular element. I am removing it. See this? Once I remove, next when you print, what happens? So 4 is not there. Earlier 4 was there now. Earlier 4 was there, but now 4 is not present. Lastly I am saying clear, and then if I print, there are no values only. Getting it now? So this is how it works. So now if I want to check, null value is not allowed in ArrayDeque. Understood? It supports dissimilar, but it does not allow null value. Okay, and it stores the values in the same order as inserted. And that is what you learnt here now. Stores values in the same order as inserted. It allows dissimilar values, does not allow null value. Understood? So that's how it works. Fine. Next, let's go to the next example, where we'll see in this example how ArrayDeque gives you the support of double-ended queue. This is the example. First example, basic it is. The second example I'm opening up now. So in this example, we are going to see now how ArrayDeque acts as double-ended queue. Okay, so it's all about methods. Okay, if you see the API or documents, Java docs. See, these are called as Java docs. What I'm showing you now is called as Java docs. Okay, so whenever Java gives you the library, for that library they'll give you the document. Okay, means you see, now when they write classes, you can't go and study each and everything of their class, source code and all that. So what they do, they prepare the document and release it like this. So we see it here. Okay, in this document, these are called as Java docs. Okay, so Java document, or Java in short they are called as Java docs. Go through the methods here carefully. Here you can see there are some methods here: offer first, offer last. Okay, peak and peak is there, then poll first, poll last. So these are different methods, okay, if you use, which makes it as a double-ended queue. Again, you have got some method called as push and pop. So if you use the push method and pop method, same ArrayDeque class becomes what? Stack. So it's the order in which you call the methods makes it as what? A double-ended queue, or basic queue, or even stack. Okay, so here right now I'll be focusing on what now? Double-ended queue. So in double-ended queue, what's going to happen if you see the diagram? Yes, see this. You can add and delete. It means you can delete and insert in the front end, both you can do. Unlike a basic queue. Basic queue what? Front end is remove, rear end is add. But here means first in, first out there. But here what happens? You can do add and remove in both ends. So that's what I'm going to show you now. First initially I show you this part. What I'll be showing is how to do insertion and deletion in the front end. Then when I complete that in the same queue, what I'll do is I show you how to do insertion and deletion in the rear end. So this is what you're going to see now. So let's see this now. Yes. See, it's all about the methods. If you want to use, see, using ArrayDeque as a double-ended queue, fine. Here, see, if you use offer first, look at these methods now. The methods, offer first, peak first, poll first. If you use these methods, automatically it becomes what? Means you are working with the front end of the queue. You are working with the front end of the queue. Okay, offer first will do what? It will insert in the front end. Peak first, what it will do? It will give you the head of the queue, but from front end. Okay, but it will not remove the element. Poll first, what it will do? It will give you the element from the head of the queue, but removes the element. That's the difference. Okay, so all these methods are important now. So we'll see now how your ArrayDeque is going to give the support of double-ended queue. See the first one now. I created the object and I'm using generics, notice. Okay, so I'm adding offer first. Means initially no values will be there. But I said 10, yes, the first value gets added now. Okay, then I'm adding 20. But where am I adding now? Offer first. Means I'm adding it to the front end. I'm adding it to the front end of the queue. Generally you add where? In a basic queue, where do you add values? Rear end. But here I'm adding values in the front end. How did I add it? By calling a method called as offer first. That's it. So if you use these methods, it will make it, okay, see here, 20. So this is how it goes on adding the values. Then next what? What is the value I'm adding? 30. Then 40. Like this it starts growing. It's a dynamic array. ArrayDeque is a dynamic array. You can add any number of elements. Then, so it will add. So after adding all the values, if you print SOP, it will print all the values. But in what order? 50, 40, 30, 20, 10 it will print. Not in the same order what you inserted now. Till now it was storing the values in the same order as inserted. But this time it will print what? I have added as this. So don't look at this now because I went with what? Adding values in the front end. So that's why it will be printing as 50, 40, 30, 20, 10 now. Done? Okay. Now let's come to this method now. Peak first. What does this method do now? It gives you the value from the head of the queue. Yes. But does not remove the element. Peak first gives you the value from the head. Now which is the head now? 50 is the head of the queue. Okay, so that's the terminology now. Head is the terminology used in what? Queue data structure. So it gives you the head but does not remove the element. But if you want that element and to remove it, you can go for what? Poll first method. So poll first method, what it will do? It gives you the value plus it will delete it. So it will give you, means when I call poll first, yes, this time 50 will be deleted. Again when I say poll first, it will give you the value and 40 will be deleted. And these will be the values now. What will be the values now? 30, 20, 10. Now in this order only it will be there. So let's see this output now first. Yeah, come to this program now, all values. See, first I'll show you one basic output, all values. Just I'm adding it and printing now. What is the order you can expect? Not 10, 20, 30, 40, 50. Instead it will be what? 50, 40, 30, 20, 10. Because I said offer first. I didn't say add. So that is why if you want the support of double-ended queue, don't use add method. Add method they are supporting to add an element because it is there in the collection interface. Understood? But if you want the double-ended queue support, better you go for these methods. Understood? So offer first. Then next, add also will add the element. Offer first also will add the element. But the behavior is very important now. If you want the double-ended queue support, keep calling these methods. Done? So then next, see, get head from the front end of the queue. Let's get the value now. Yes, peak first. I'll get the value. Get head of the queue from front end now. See, till now we inserted. Now what I'm trying to do? Get the value. Where did I insert the values? Front end. Okay. Yes, I'm getting the value 50. But here, this peak first method will not remove the element. But if I want, I can remove it. How will I remove? With the help of poll first method. That's it. So in this, what will this poll first method do now? It gives you the value plus deletes the value. Yes. So now see, it is giving you the value plus it is deleting it. I show you one more output you can notice. See, again I am saying poll first. One more time I am saying poll first. So once I say again poll first, now what will be removed? 40. And after removing all the values, means after removing those two values, if I print SOP this one, what will be the answer now? 30, 20, 10. Yes. Because we have removed 2 by using what? Poll first. So what does the poll first method do? Gives you the head of the queue. Okay, means it gives you the value from the head of the queue and removes it. But this is happening in which part? Front end of the queue now. So poll first and poll last, poll first method. What does the poll first method do? Gives you the value from the head of the queue, but from front end. Gives you the value from head of the queue, but from front end. Gives and removes the value from the front end of the queue. Done? Okay. So then next, we'll see how to work with the rear end. Understood? Are you clear this now? What does the poll first method do? What does the poll first method do? It gives you the value from the head. It returns you the means it is poll first method. Okay, it gives you the value from the head, but from front end side. Front end side it will give you. So that clearly shows now what? We can add and we can insert and delete values from what? Front end now. This is the concept what is on. We can insert also plus delete also. So next I'll go with that side now. Which one? We can insert and delete from rear end. Let's see how it happens now. So for that, which methods I'll use? Very simple. All I'll be doing is what? Offer last. So these values will get going on offer last. We'll add the values in the rear end. Understood? Rear end or tail end, anything you can think. Okay, that's the queue terminology, what we say. Okay, see I'm adding now, offer last. Where is 11 added now? Here. Next I'm adding 12, where it is added? 22. Then I'm adding 33. Then I'm adding 44. Fine. So now you are inserting values into the rear end. Understood? And at the same time, you'll see the output now. So now see, this will be your output now. Yes, correct now? Fine. After that, next, let's see this. I'll say peak last. What will peak last do? Gives you the value from the head, but this time it will give from tail end. Okay, but we are peak last we are saying. Peak last. Earlier we are saying peak first. So peak method always gives you a value, but does not remove it. But this time it is giving you from the head only, but this head is from rear end. Understood? It will give you from the rear end, but it is not removing it. So it is giving you 44. You can see 44 is in the last, it is giving you that particular value now. Done? So head of queue from rear end. You can see the output now. Head of queue from rear end. Next what I will do is, I will say one more method is poll last. I'm calling it twice. So you want to call it twice, poll last, poll last. Okay, it removes that from the rear end of the queue. Poll last is going to remove the head from rear end of the queue. It will remove it, it will give you plus remove it. Okay, so let's see this output now. And finally when you print, see you are removing, we are saying poll last twice. So which two values will be removed? First 44 you will get, then you will get 33. So and finally in the last, when you print, this will be your answer. Means when you print in the last, all values after poll. So this is how you can see how ArrayDeque supports double-ended queue. So 30, 20, 10, 11, 22. So this time we went on to insert and delete the values from rear end. So in double-ended queue you can do insertion and deletion from both the ends. Done now? So it's all about the order in which you call the methods. Clear this? Okay. So this is what is a double-ended queue. Now we'll go with the next example. The next example is ArrayDeque demo 3. So in this example we'll see how ArrayDeque can be used as a stack. That's it. Very simple. We are calling which method now? There we are using peak first, peak last, poll first, poll last for double-ended queue support. Now which method we are using? Push method and pop method. So it is the methods which you call now, which makes it as behave as a double-ended queue or stack. That's it. So push all the elements A, B, D, E, F. Internally it will be stored in array. You don't worry now. Okay. And now we are saying ADQ.peak is not equal to null. Not equal to null means what? Value is present. Value is present, pop it out. When you call the pop method, what it will do? It will give you what? Last in, first out. Because it has to support what? Stack. So when I call pop now, even though you added A, B, D, E, F, pop method will be giving you the first element as what? F. Because it is stack. Simple, very simple here. See, this is the way you have inserted. And this is the output how you are getting. Yeah? So this was the new introduction, and ArrayDeque can support all the three: basic queue, double-ended queue plus stack. Okay, so it is more recommended to use ArrayDeque as stack now rather than using legacy stack class or using linked list as stack. It's better you use this because it has much better efficiency as compared to that. Yeah, fine. So this was one of the introduction, means in Java 6 to support the collections framework. Such a terrific concept of a double-ended queue has been simplified and given to the Java developers in a simple class called as ArrayDeque. Okay, then in the API you can see in the library other things which were added were NavigableSet and NavigableMap. Two interfaces were added. Okay, so why did they add these two interfaces? Yes, we'll see it. First let's see where it is added in the hierarchy. See, earlier your collections in up till 1.5, okay, you didn't have the NavigableSet. Tree set was directly implementing what? Sorted set. This was the hierarchy. The tree set was directly implementing sorted set was extending set was extending. This was the hierarchy. But in 1.6 this was added. Understood? So why did they add this? That also we'll see. So now the methods present in NavigableSet can be used only by tree set now, or the classes which implement NavigableSet can use it. That's it. So that's where it stands in the hierarchy now. But HashSet cannot use it. Don't get confused because it is set now. You think that it can be used for other set classes also. It can be used by only a class. Which are class implements NavigableSet. So tree set is implementing it. Where does NavigableMap come now? Yes, again you can see here tree map is implementing what? NavigableMap. So if you understand NavigableSet here, it's almost all you have understood NavigableMap. So concentrate on one. I'll show you the different methods. Now why was it introduced? Very simple, let's see this. What is NavigableSet? Okay, so see, end of the day it is implemented by tree set. So if you know tree set, almost all you will understand what now? NavigableSet. But before understanding NavigableSet, you should know the tree set in a perfect manner. Then only you can understand NavigableSet, because it is implemented by tree set. Tree set I already covered for you. I already covered your tree set data structure. So just we have to understand just a few methods which are present in NavigableSet, which is available for the tree set class today. Understood? So yes, NavigableSet was added in Java 6. It is extending sorted set. It is implemented by class tree set. Yes. Why it was added? It provides various methods to navigate or search through the tree set collection. Only for navigation purpose. Navigation means what? Visiting the elements and searching the elements. In the tree set, if you want to search now, okay, they have provided some extra methods. And again, if you want to navigate now, they have provided some extra methods. When I show you an example, you will automatically understand. Navigating means either going from top to bottom or bottom to up. That kind of navigation. Search means you will give some particular value. It will give you the value very. If you give an, let's see it with an example. I'll just show you. Understood? So it will help you to navigate or search through the tree set collection. That's it. So now NavigableSet directly see an example itself, or we can go through the docs first. It's an interface, NavigableSet. So there are some extra ceiling and descending set, floor. These are the extra methods what they've added. Some 8-10 methods they've added. That's it. Let's see the few methods which they've added. Yes, you can go to the second project now in the same workspace. com.cluster package, NavigableSet demo. So as you know now, I'm creating an object of what? Tree set. And I'm adding the values now. What values I'm adding? 3, 2, 5, 8, 15. So it will be stored in alphabetical order because it's using tree set data structure. So fine, all that is okay for us. You know about all this. So elements in the current set it will print. What it will print? You are inserting in this order, but when you get the values now, it will be giving you it in ascending order. So this is pretty clear for you. There's nothing big about that. Okay, let's see the output. And then you start saying, see this. Yes. So I put it in this order, but it's printing me in ascending order, default. Understood? Yes. But I want it in reverse order. So earlier you didn't have any methods to support that. Okay, or it means it was pretty difficult to navigate. So right now by default you are navigating in what style? Top to bottom. But I want to navigate how now? Bottom to top. Navigating means visiting the elements. By default it is going from top to bottom, but now I want to visit from bottom to top. So you call the method descending set. Yes, this is the new method which has been added in NavigableSet. So descending set, when I say, yes, the return type is what? One more set object. It's one more set object. Okay, and in that new set object, you will have values in descending order. It's one more, different one it is. But you will have it in descending order. Okay, and remember this is called as backed collection. Backed means, a new word I am introducing, any changes you do in that set will reflect in this set also. Means by chance if you remove in set, understood, it will be affecting in what? Descending set. They are totally backed by each other. Any changes done in this set will be affecting that set. You can, if you insert there one more extra, okay, it will insert here also. We'll see that, you'll understand. So now see this now, it's called as backed collections. Fine, now I'll add an element here. Set dot, no, where I'll add, okay, I'll add it here. Not there. Descending set dot add. I'll add something like 99. When you add 99 now, what will I do? Again I'll print both. Let's see the result. See, I added in which one? I actually added in descending set, but it has got added in what? Set also. This is something called as backed collections. It is backing each other. If you do some manipulation there, it will affect here. If you do any manipulation there, it will affect. Because they are two different, even though they are two different objects. See, this is on different object. Descending set is on different object. Or I'll name it as set. See, this I'll name it as set 1. This I'll name it as what? Set 2. Any changes in set 1 will affect set 2. Any changes in set 2 will affect set 1. Means this is what you mean by backed collections. They are backing each other. Understood now? Anyway, so we can navigate in what now? Backed collections separate, leave it now. They are backing each other. But descending set is allowing you to navigate what? From bottom to top. Navigation. You are visiting the elements from bottom to top. Understanding now? This one? Fine. Yeah, so this is done now. Next. After that, yes, let's come to some methods now. You got the clear with the first method, what is descending set? It returns you one more set object, but in descending order. Done. So then next, we'll go with next method called as ceiling. These are all methods of which one now? Navigable set. So fine. Set 1 dot. Okay. In the navigable set, now see now I'm in the set 1, I'm calling ceiling. You can call these methods in any set now, but I'm working with set 1 now. Okay, fine now. So ceiling of 6, what does the ceiling of 6 mean? Okay, see 6 is the value I am passing. Who is passing? The developer is passing. So in that set now, what it will do is, if you give this value to the set, tree set, it searches, okay, for the nearest element to this. Now what do you mean by the nearest element? Either it should be equal to 6 or higher to 6. The next element now, the immediate next element, which is equal to 6 or higher to 6. So now what are the values we have added now by default now? We have added 3, 2, 15, 8, 5 and 99 also added. Fine. One more we added now. So fine. So now what I'll do is, I will say, okay, ceiling of 6, fine. So now it will try to get me the equal value. Means I am passing in the, for the set I am giving a value. What value I am giving? 6. So what will the set do with this value? Now it will check, is there a value of 6 or greater than 6? That value it will give you, nearest value. So it is searching now. Till now we saw navigation support. Now we are seeing what? Search support, which is given to you by NavigableSet. So it searches and gives you the equal value or the next highest value. Equal or highest. Okay. So is there an equal value called as 6 here? No. So it will give you the next highest value now. Which is that? 8. So this time the ceiling method, when you call it, it will give you an integer. Return type of that is integer. But it will be giving you what? 8. Sorry, yeah, 8. But higher value, what it will do now? Almost all same methods. It will always give you higher value. Ceiling will give you an equal or higher value, but higher will always give you a higher value, even if it is there. Supposingly 6 was there, it would have given you what? 8 only. We'll see it with an output, it will always give you a higher value. Yes, first see this. So yes, what is the ceiling of 6? Equal or higher? 6 is not there. So obviously the next highest value is what? 8 here. So it will give you 8. But higher of 6 means, it will definitely give you highest of what? Higher than 6, but not completely higher, it will give you the immediate higher. Understood? Fine. Now see this, to make it very clear, I will give the value as 8 now. Here also I will give the value as 8. So now when I say ceiling of 8, this time it will give me 8 only, equal or higher. So it has found the equal match. This is how it's searching now in the set. It is finding the equal one. If it finds, it will return you that value only. If it doesn't find, then it will give you the next highest value. So this time we have 8. So ceiling will give you 8 itself. But higher will give you 8, the next highest value only. Higher will never give you the equal value. It searches and gives you the next highest value only. So obviously it is going to give you what? 15. So the answer will be what now this time? 8 and 15. This is how it works. So ceiling will give you equal or higher value, next equal or next higher value. So ceiling gives you equal or next higher value. Equal or next higher value. But higher will give you what? Higher method will give always next higher value only. Next higher value. Always next higher. Even if it is there, it will not look for the equality. It will give you the next highest value. And that's what is happening now. So like that, next I'll give you something like, which value I'll give? 15 I'll give. Yes, you tell me now. Ceiling of 15 and higher of 15. What would be the answer? Ceiling of 15 is 15 only. Higher of 15 will be what? 99. Okay. Now by chance, I'll give you ceiling as 99. Higher as 99. So what will be the answer now? 99. So it will give me 99. Okay, equal or higher. Okay. But this time higher will give me what value? It is not there. There is no value higher than 99. So it will give me null value. So that is how it works. See here clearly the documented. Returns the next element. First is ceiling. Returns the next element in the set greater than or equal to the given element, or null if no such element is present. Same way here also. What will higher do now? Returns the next element. Yes, this is what you saw now. Or null if there is no such element. Higher only it has to give. When it is not there, what it will do? Null only it will give. Supposingly I give 100. What will happen now? Both I will give 100. Both will be null. Equal or higher? For ceiling also it is not there. Higher also it is not there. So both values will be given now as null only. Done? So like that. So if you understood what is ceiling and higher, floor is very similar now. But it gives you the lower value. That was giving you the next higher value. Lower is going to give you the lower value. Next lower value. Okay, we'll see that now. Yes. So what is the floor going to do now? Equal or next lower value. Understood? Equal or next lower value. Very important interview question, and it is asked in SCJP. This floor, these methods are definitely asked in SCJP. Floor will give equal or next lower value. Then lower will give which one? Equal or always equal, always lower value. Always lower value. Always next lower value. Otherwise, if the okay. So 8 of floor. Directly you tell me the answer now. 8 of means I'm telling floor of 8. What will be the answer now? Equal or next lower value. So it will be 8 only. Then lower of 8 will be what? 5. Lower of 8 will be, means always lower value. Understood? Floor will be equal or lower value. Floor will be equal or lower. Lower will be always lower value. Next lower value. Next lower value. So don't think here lower means full least. It is looking for the next one. Understood? Don't think lower and higher means full high value and full low value. It will be looking for the next one. Means it is searching now. Okay, it gives you the nearest search. That is what you mean by this point now. We had mentioned. It is giving various methods to navigate or search to the tree set collection. The nearest search, whatever is found, will be given now. Understood? So these are the methods which are added in NavigableSet now to support what? tree set for navigation purpose and for search purpose. Done. So if you are clear with this, next we'll go into navigable map. Same thing now, but there will be navigating through what? Navigating and searching through key value pair, that is maps. So you should know for that what? Tree map. For this you should know tree map now. Okay, navigable map is equal to new navigable map. Yes. So here also I will change it like this. I'll name it as map 1. Yes. And this I'll name it as map 2. Because it's a backed map. Same concept. There you saw descending set. No, here you are seeing what? Descending map. Understood? So map, navigable map. Here I am using generics. Key will be always of type what now? Integer. Value will be always of type strings. So this is the type argument. Are you following now? We are specifying the type arguments. So then next elements in the map are, fine, it will print in what order? Ascending order of keys. So even though I have added like this 9, 3, 2, 11, 17, while printing it prints what? 2, 3, 9, 11, 17. That's the order it will print. But descending map will print in what? Descending order. So in map 1 you will navigate in what style? Top to bottom. But in map 2 you will navigate in bottom to top, but descending order. In map 1 you are navigating in ascending order. In map 2 you are navigating in descending order. That easy. So again, why did they use these methods? For navigation purpose. So some methods have been provided for navigation purpose, some methods have been provided for search purpose. Understood? So we'll see this output first and then so in map 1 see there are two different objects. This is map 1, this is map 2. Both are having same value, but one is in ascending order, the other one is in descending order. So how you want to navigate? Navigate now. Done. But again, this is backed map. Backed map means any changes you do in map 1 will affect what? Map 2. Any changes you do in map 2 will affect what? Map 1. Done. So be careful when you do the modifications. When you are having a backed one, okay, so be careful because any changes you do there will definitely affect this one. Either way, vice versa now. Map 1 change will affect map 2, map 2 changes will also affect what? Map 1. Okay, this I showed you in what? Set. Backed collections I showed you. Understood? Backed. We call them as backed collections. It is backing or backed maps. This is the terminology. Backed maps, backed collections. Yeah, means changes done in this map will be affected in that map. Same way backed collections means changes done in this set will be in collection will be affected in the other collection. Done. So fine now, this is done. So very simple. So next we'll go with the next method called as descending key set. So what is this method going to do? It gives you one more set object. It will give one set object, but it will contain only what? Keys. Keys in what? Descending order. One more different object only it is. Understood? But it is containing only keys. So descending map will contain key and value. Descending key set will contain what? Only keys. So see now the output. See only keys in descending order. Fine, next we'll write some more methods. So the next methods which I'll introduce are map 1 dot first entry, map 1 dot last entry. So here first entry and last entry does not mean what you added first and what you added last. Okay, first entry means the first value in the data structure. Which will be the first value? It is in ascending order now by default. So the first value will be which one? 2. So now when you say first entry and last entry, it will be considering the data structure, not the way you have inserted the values. Okay, so let's see this output now. See, first entry is 2, Last entry is 17 and Arjun. Okay, means, but actually first what I added was Ravi, 9 and Ravi, but first entry is giving me what? 2 and V9. Understood? So it will give you the first value in the data structure. Last entry will give you the last value in the data structure. And since it is tree structure, it is storing the values in ascending order. So that's why it's giving you like this. So that is, again it is searching. This is nothing but what? Search. First entry, last entry. So they are searches. Fine. Then next. I think we'll comment this one now. Which one? All this will comment now. And now we'll go with which methods? The search methods will go. Yes, now you can see which one? Ceiling entry. Now you should be able to tell me now. Ceiling entry means what? Ceiling means what? What is ceiling? Equal or next higher value. Equal or next higher value. See, but it will give you what? Key and value. This method will give you ceiling entry. It will give you an object. Okay, it will give you an object. But that object will contain what? Key and value. If you want only the key, call which method? Ceiling key. So, what is the value I am giving? 9. So, equal or higher. Is there a value equal now? What is this time? What values we are adding this time? In the map, what are the values we are adding? 9. 3, 2, 11, 17. Yes. So we are calling now ceiling dot entry of 9. So equal or higher. So 9 only will be given now. 9 with value, whatever the value. Okay. This one also ceiling key, what it will give? Higher only. And that will be 11. Equal or ceiling will be equal or higher. Sorry, no. Both will give 9 only. We are talking about ceiling, no? So we are talking about ceiling. So ceiling entry and ceiling key. Ceiling entry will give you key and value. Ceiling will give you only key. That's all. Ceiling key. That's it. So it will give you now. So let's see the output. So both will be 9. Yes, 9 and Ravi. Which one is that? Ceiling entry. Ceiling entry will give you what? Key and value. But ceiling key will give you only key, which is 9. Okay, now we'll change some other value. I will say equal or higher now. I will tell 8. Still what value will I get? What is the value I will get? Equal or higher? The next higher value, immediate. Understood? The next higher value. Equal, it will look for 8. If it is not, 8 is not found, the next higher value. So obviously it will be 9 only. And don't think after 8, 9. It's like this here. If I give 6, what will be the value next? What you will be getting? Again, equal or higher. Again it will give 9 only. Understood? Yes. But if I give 11, yes, this time it will give me what? 11 value it will give me. Amount it will give me. Equal or higher. Getting it now? Yes. Same with what now? Floor entry. Understood? What will floor entry do? Equal or next lower value. Equal or next. And the floor entry will give me what? Key and value. Floor key will give me only key. But lower. Equal or lower. Equal or lower. Both. Done? So lower of 9 it is found. Equal or lower. So 9 is there, it is giving you that. Okay. I showed you 4 methods. Which are the 4 methods I showed you? Ceiling entry, ceiling key, floor entry, floor key. If you refer the docs for NavigableMap, ceiling entry, ceiling key. Okay. First entry, floor key. Some more methods are there. Higher entry is also there. Higher will give you what? Always higher one. Higher entry, higher key. Then you got lower entry, lower key. There are 4 methods. Ceiling, higher, floor, lower. So higher will be always higher value, lower will be always lower value. Go through that. And all methods you cannot understand in one day. Okay, gradually as you go on using it, you start understanding. So see, these are the concepts, and Java is only giving you what? The support for it. We don't write the logics. Understood? So this is how it works, and these are the different methods. This was, we saw NavigableSet. Now these are the nodes for NavigableMap. Almost all same. Was added in Java 6. It is extending what? Sorted map, and it is implemented by tree set, and it is providing various methods to navigate or search through the tree map. This is how it happens. Done? Okay, see, these are the terrific concepts what you got in Java, and Java is only giving support. We don't write logics. In other languages what happens, or in most of the languages, you have to understand the concept also, implement it also. But in Java, we only go on to learn concepts. So from day one I am teaching you concept. I am never teaching you how to write the output here. Okay, this output whatever I am showing you is to prove the concept. So always see the output as what? Concept. Don't think you are getting output. See the output as concept, then you will start understanding better things. Understood? So more concepts you know, you will understand Java's libraries in a much better way. Okay, fine then. So this is about this. Yeah. See some more. In the last session I had discussed about what? Okay, one thing now, just before I move on. See collections, how important it is. See if you are working, there are generally 4 or 5 types of collections. There are generally 4 or 5 types of applications we develop. Okay, like standalone applications. Then you might develop web-based applications, or you might develop mobile applications, or you might develop distributed applications. There are many types. In all these applications, collection plays a major role. You cannot write a logic without this. Why collection plays a major role? Because it is dealing with data structures. So when you have so much of data, you have to organize it. So Java is giving you tremendous support for data structures like this. So in fact, the amount of collections what I covered for you is equal to around a person with 3 to 4 years of experience. That much of collections I have covered. Okay, you might be thinking it is basic because you have never seen other places how they teach collections. But here what I covered is equivalent to minimum of 3 to 4 years of experience. And second thing is, say, collections, how important it is from interview point of view. You go to any interview, fresher interview, experience interview, or even go to SCJP, you want to give the exam. Okay, see anywhere you go, supposingly if your interview goes on for 1 hour, minimum, okay, 15 to 30 minutes, your interview will be only on collections. That important it is. Minimum 15 to 30 minutes. So put a lot of effort and learn collections in a proper way so that it will be helpful for you in your lifetime. And I put it in a very easy way to you. Understood? So that important it is. So better work with collections a lot because it's used in all type of applications. You go to any Java interview, okay, it is definitely asked. Not only Java, in C also you go they ask, but they talk on data structure concept. But here we talk on the implementation concept, classes concept. You go in C, C++ also they'll ask you what? Data structures only. So here instead of talking data structure directly, because that is abstract for us. All data structures in Java is what? For the developer? Abstract, we don't know. We only work with that data structure. So that is why it becomes very, very important. You go with any years of experience. See, supposing you put 4 years of experience, definitely interview will be for 30 minutes. Only on what? Collections. So that important it is, put more effort. Yeah? Huh? Yeah. So the last thing what I have to cover for you today is on the yesterday's word which I told you, refined and non-refined. These two words I have to discuss. So refined and non-refined. See, these are terminologies. Right now as a fresher, not that very important for you if you are a fresher. But gradually as you go on learning Java or working in Java, these words will come across when you are reading very big books, because initially you are reading very introductory books, but later on you start reading big documents or higher concept of books written by big authors, and they contain more concepts. So in those books you'll be consistently finding this word, refied, non-refied. It's very simple. See, non-refied means not existing in runtime. That code will not exist in runtime. A good example for non-refied is generics. And generics does not exist in runtime. Okay, see, example is, I'll just show you now. See, this is my source code. In source code I'll write set integer set is equal to new tree set integer, and I use this. Understood? So this is what you do. But this is in .java file. When you compile this, you will not be finding what? The which one? The generics. This type argument you will not find. Why? Because of type erasure. Your generics type what you have used, it will be erased by the compiler during compilation. Understood? So it will be removed. So and in the .class file you will not find it. Finally, what is getting executed? Your .java or .class? .class. So what is there in .class is actually loaded into the JVM. So even though your generics is there in the source code, it will not be available at runtime. So that is why we say it is non-refined. Generics is non-refined. Just I'll show you. See, I've used generics here. See, one more. Generics will non-refined. Non-refined means not existing. Refined means what? Exists at runtime. Will exist in runtime. That's it. Opposite of it. Understood? So yes, I'll show you here. See, this is your code here. NavigableMap. I've used what? Key value as generics. I'll just show you now. NavigableMap. You go to that location where your .class file is. Copy this path, means go to that folder where your project is there. Paste that path. Yes, we are here, and see, this is your project. Sorry. And this is your project now. In your project in SRC, what you'll have? Source code. Bin will contain what? .class. That's how Eclipse is storing. So I'll open it the decompiler. So you should have installed a decompiler for this, and I'll say open with Kawaj. Kawaj is the decompiler I used. Now see, there is no generics in the .class file, in the bytecode rather. But actual source code is like this. Integer, string, you're using it. And you're not finding it here. So it is this code which goes into the runtime actually. Okay, so since generics is not available at runtime, it is called as non-refined. Understood? So this is only a concept. Very rarely they ask in interviews, but for your information I gave you this. But gradually they start asking in interviews because these are all new words. And over a period of time, 1 year, 2 years down the line, all this will become very important interview questions. Understood? So fine. Then next, some notes on this. You'll find it here. I think I showed you the notes for NavigableMap.
Third point is
we'll come to that once again. Yeah, first time I'll complete this section. Refined and non-refined. See, generics. Sorry, where is it? Yeah. See, generics code is available only in source code and not in bytecode. The process of removing generic type information is called erasure. Okay, this is definitely an interview question today. What is erasure? They'll ask you. It is done by the compiler during compilation time, and generics is non-refined, means not available at runtime. Okay, that much is more than sufficient for you. And you want the notes for NavigableMap? It's in the last. Okay, see this one. So it's implemented by tree map. Make that change. Understood? It's implemented by class tree map. That's it. Okay. So then Yeah, I think this would complete everything. So work good on collections. That's my last message to you. Otherwise, it means because in all interviews, definitely this is a major questions will come from collections itself. Okay, that's it then. Huh? One second. Yeah. Okay. And one more thing, what you have to understand is in Java 1.7, what happened? 1.6 we have covered. Good. So in 1.7, what has happened is, so it will not work here, but just I'm trying to tell you. See this, if you are using generics, okay, earlier you are giving key value pair in object creation style also, here also. But in 1.7, they have removed it. You don't have to give it. Okay, but here it gives you error because we are using 1.6. Okay, and this empty operator is only called as diamond operator. Diamond. This is called as diamond operator. Okay, there are some reasons why they gave it. Gradually in your coding you will understand. Understood? The reason why, okay, anyway, just I will undo this. Yes, understood now? So now why did they do that? You might have a question. Okay, I'll just tell you, but gradually you'll understand this in later part of your coding life. Okay, the reason why they removed it is, see, supposing I have an hierarchy of animal and dog. There are two classes now. Dog is extending what? Animal. So see this now. A list. Generally we say a list is equal to new array list. Yes, valid code. Why? Superclass can refer to what? Subclass object. This is possible. But when it comes to generics, list of animal equals animal is valid. Understood? But a list of, this is correct, but this goes wrong. So superclass and left class, subclass, it is correct for your what? Creation of object now. But in generics, superclass variable and subclass variable will not work. This is wrong. Okay, so this is wrong, and the developers were getting confused now to use generics. They're getting confused to use generics. So that is the reason what they thought, why unnecessarily specify here also, let us remove this. So that is the reason what happened. They said now you just say list animal, list is equal to new array list, just say the diamond operator. Internally it will only take what? What you have specified here. So no confusion only this time. What you have to specify. So they made it more easier in Java 1.7. Using generics has been made. You know what is the power of generics, you know. But using generics was a bit complicated here, and their confusion was there. That confusion they eliminated. So this is called as diamond operator. Understood? And this will be generated, you know what happens now? Anyway, erasure will happen. Even though we are not writing the code, compiler will be generating the code for you now. So it knows what to add there. Okay. Clear? So this is one major change what they did in 1.7. There is a technical reason, simply they will not do it. Understood? So this was one of the major change which happened in Java 1.7. Done? Okay. That's it for the day. Stella?